Machine learning becomes valuable when it leaves the notebook and runs reliably for real users. That's where MLOps comes in. In this course, we'll connect models, cloud, containers, CI/CD, and monitoring into one practical production workflow. We'll move in two stages. First, you'll build a foundation in MLOps concepts, lifecycle thinking, tools, and production patterns. Then you'll apply those ideas by building, packaging, deploying, monitoring, and improving a simple model end-to-end. Think of this course as a guided path, not a tool catalog. We start with the big question: why production machine learning needs MLOps? Then we connect DevOps ideas like automation, reliability, and collaboration to machine learning work. From there, we unpack the ML lifecycle and the tools that support it. Finally, we bring everything together in a simple deployment flow. Use this course based on where you are today. If you're new, move in order and give the core ideas time to settle. If you already work in DevOps, IT, or data, pay close attention to deployment, automation, and monitoring. If you're more advanced, treat the course as a reference. Most importantly, keep tying each topic back to the production ML lifecycle. Prepare, train, deploy, and improve. Let's begin with the core question. What is MLOps? At a high level, it is the bridge from model experiments to reliable production systems, supported by DevOps practices, automation, infrastructure, deployment, and monitoring. A model that works in a notebook is only the starting point. To create real value, it has to become a reliable system, served through an API or batch pipeline, packaged for deployment, and run on infrastructure that can scale and stay secure. Teams also need versioning, automation, monitoring, and alerts, so they know what changed, whether performance is drifting, and when to intervene. Production is the engineering around the model. MLOps is the operating system around machine learning work. It connects data, model development, engineering, infrastructure, automation, governance, and monitoring into one repeatable lifecycle. The key shift is that success does not end when a model is trained. A model has to be deployed, watched, updated, and controlled as real data changes. MLOps gives teams the practices to make that happen reliably. Traditional DevOps assumes the main thing changing is code. Once the application is tested and deployed, it should behave predictably. Machine learning adds another moving part, the data. As customer behavior, sensors, markets, or environments shift, model performance can drift even when the code stays the same. That means operations must include dataset tracking, experiment history, model metrics, versioning, retraining, and validation. MLOps extends DevOps to manage that living system. In traditional software, code is usually what we build, test, and ship. In machine learning, code is only one part of the system. The data shapes the learned behavior. The training configuration changes the model. The evaluation metric defines what good means, and the environment affects whether results are reproducible. Production, ML requires tracking the whole package, not just saving a model file. Repeatability means every model result has a trail behind it. We know which code version ran, which dataset was used, which parameters were chosen, and which metrics came out. When those details are captured automatically, teams can rerun training, compare experiments, and register the exact artifact that produced a result. This removes guesswork. Instead of "it worked on my laptop," MLOps aims for the same outcome across environments. Automation turns MLOps from a set of manual handoffs into a repeatable system. When code or data changes, pipelines can train, validate, package, and deploy with checks at each step. If tests fail, the process stops. If metrics pass, the model can move forward. This reduces human error, speeds iteration, and makes releases more consistent. The goal is not just faster deployment, it is safer, more trustworthy change. Once a model is deployed, the goal shifts from accuracy alone to dependable service. Real-time users and batch jobs need consistent responses, even as traffic changes. Containerizing the model makes the runtime repeatable. Orchestration can restart failed instances, scale capacity, and roll out updates safely. Monitoring then closes the loop by tracking latency, errors, resource use, and prediction behavior. When something breaks, alerts and recovery processes keep small issues from becoming outages. Governance keeps machine learning from becoming a black box in production. A team should be able to trace a prediction system back to the dataset, training run, model version, approval decision, and deployment event. That record makes reviews, audits, rollbacks, and compliance checks possible. The key mindset is simple. Before a model serves users, prove it was evaluated, approved, logged, and can be explained later if something goes wrong. Deployment is not the finish line. Once a model is serving real users, its environment keeps changing. MLOps teams track service health, latency, errors, prediction patterns, and business performance. When data drift or model drift appears, feedback and fresh data feed the retraining process. The updated model is validated, redeployed, and monitored again. This loop turns production from a one-time release into a controlled system for continuous improvement. Great work! You now have the foundation. MLOps turns models into reliable production systems. Next, we'll explore why DevOps engineers are especially well-positioned for this work.